the 29th of October, 2025, 11:47 Universal Time. Something impossible just happened behind the Sunday. 3I Atlas. Are we alone? 3 interstellar objects detected. 2 clearly natural. 1 ambiguous. 1 generating serious scientific debate between credentialed researchers at top institutions. That has never happened before in human history. Scientists have speculated. Science fiction has imagined. But never before has Harvard published quantitative analysis suggesting specific observable object might be artificial. This is new. This is unprecedented. This matters. Even if answer is natural comet, the fact that question was raised seriously matters. It means detection is possible. We have instruments. We have capability. We have scientists willing to consider hypothesis. Next time another interstellar object appears, we will be better prepared. Better protocols, better coordination, better data collected earlier. 3I Atlas is teaching us. Whether natural or artificial, it is teaching us how to investigate. And universe keeps sending objects. Oumuamua. Borisov. 3I Atlas. 3 in 8 years. Statistical models suggest 1 or 2 interstellar objects pass through inner solar system per year. Most go undetected. Too small. Too dim. Wrong timing. But detection capability is improving. Better telescopes. Better surveys. Better algorithms. We will detect more. Next year, year after, decade after. Trickle becomes stream. Each object teaches. Each object tests theories. Each object adds data. Maybe 3I Atlas is natural. Maybe next one is artificial. Maybe one after that. Eventually, if technological civilizations exist, if interstellar probes travel between stars, if galaxy contains intelligence, we will detect unambiguous proof. Maybe today is not that day. Maybe today is just interesting comet. But maybe today is beginning. First hint. Opening move. Acid test. Revealing something extraordinary hiding behind Sunday. We will know soon. December. Early December. That is when we get the answer. When 3I Atlas emerges from solar occultation. When ground-based telescopes regain line of sight. When position can be measured precisely, compared to gravitational predictions. If it appears exactly where physics says it should, natural comet confirmed. If position deviates by even a few hundred kilometers, something happened behind the Sunday. Something that changed velocity. Something that altered trajectory. Clear test. Binary result. 5 weeks away. But before we reach that answer, we need to understand what makes this scientific civil war so intense. Because this is not just about data. This is about people, about careers built over decades, about reputations on the line, about scientists who devoted their lives to understanding comets suddenly facing an object that does not fit comfortable categories. Let me show you what happens when astronomers confront the unexplainable. The 15th of September, 2025. Dr. Tom Statler sat in his NASA office, reviewing spectroscopic data for the 3rd consecutive day. His team had compiled observations from multiple telescopes, VLT, Gemini, Keck Observatory. Hundreds of spectral lines, thousands of data points. He cross-referenced every unusual signature against historical comet databases going back 40 years. The nickel emission bothered him, not because it was impossible to explain naturally, but because it required specific conditions. Low-temperature sublimation, organic molecule carriers, chemistry not seen in solar system comets. He spent 7 hours that day modeling molecular structures that could produce the observed signature, testing hypotheses, eliminating alternatives, building the case for natural explanation. On September 18, he published his statement. Quote, "It looks like a comet. It does comet things. Evidence overwhelmingly points to natural body. Direct, unambiguous, confident." That confidence came from 3 days of exhaustive analysis, from consultation with colleagues, from decades of experience studying comets. He was not guessing. He was concluding based on rigorous examination. But Dr. Avi Loeb reached opposite conclusion from the same data. The 20th of August 2025. Loeb received the JWST spectroscopy results. Carbon dioxide to water ratio, 7.6 to 1. He immediately pulled up his database of solar system comets. Scrolled through hundreds of measurements. Nothing came close to 7.6. The highest ratio previously recorded was 3.2, from a comet that formed in the outer Kuiper belt under extreme cold. He sat staring at the number for 90 seconds. Then he called Carson Hibbard and Carter Crowell, his collaborators on the trajectory analysis. They spent the next week calculating what conditions would produce this ratio naturally. Distance from parent star, temperature during formation, radiation exposure during interstellar transit. They built multiple models. Each model required increasingly unusual assumptions. By August 27, they had their paper draft, not claiming proof of artificial origin, claiming the probability stack justified investigation, the multi-planet trajectory, the near-ecliptic alignment, the hidden perihelion, the anomalous composition. Each factor individually explainable. Combined, suspicious, two scientists, both rigorous, both experienced, both analyzing identical data, both reaching opposite conclusions. This is not failure of science. This is science at its rawest. Frontier investigation where answers are unclear, where frameworks compete, where evidence is ambiguous enough to support multiple interpretations. Here's the problem with that ambiguity. It creates institutional paralysis. NASA cannot allocate massive resources based on hypotheses that most scientists reject. Harvard cannot prove technological origin without better data. The standoff continues while the object moves farther away, while observation windows close, while opportunities vanish. And now the object is behind the Sunday, the most critical moment, the acid test, happening right now. And we are blind, but some spacecraft can still see it. That is the fascinating part. Earth-based observatories are blocked. Solar occultation prevents observation from our planet, but spacecraft elsewhere in the solar system have different viewing angles, different positions, different opportunities. NASA's Parker Solar Probe orbits close to Sunday, studying solar corona, solar wind, magnetic fields, not designed for comet observation, but positioned where it might detect 3I Atlas if the object produces bright outgassing during perihelion. The probe's instruments monitor particle density, magnetic disturbances. If massive gas release occurs, Parker might detect it indirectly. Stereo spacecraft also monitor solar environment, Solar and Terrestrial Relations Observatory, 2 probes at different positions, one ahead of Earth in orbit, one behind. Both study solar eruptions, coronal mass ejections, space weather. Their coronagraphs block the sun's disk to see faint structures in corona. If 3I Atlas produces bright enough plume, Stereo might catch it. ESA's solar orbiter is another possibility, studying Sun from elliptical orbit, perihelion inside Mercury's orbit, aphelion beyond Venus. Current position unknown without checking ephemerides, but potentially positioned for observation if geometry aligns. Then there are the Mars orbiters. ESA's Mars Express and ExoMars Trace Gas Orbiter already observed 3I Atlas during October 1 to 7 period, when the object passed Mars at 30 million kilometers. Both spacecraft captured images. Both detected the coma, the cloud of gas and dust surrounding nucleus. Both confirmed outgassing activity, consistent with cometary behavior, but resolution was limited. From 30 million kilometers, even the nucleus appeared as fuzzy dot. No surface details visible. No structure resolved. Just brightness confirming something is there. Something active. Something releasing volatiles. Here's what makes those observations important. They prove the object was intact on October 7, 3 weeks before perihelion, already showing activity, already developing coma, behaving like a comet. That data supports Statler's interpretation, natural comet doing comet things, but it does not rule out Loeb's hypothesis, because artificial object could also release gas, could create coma for thermal management, could mimic cometary appearance for concealment. Observations confirming cometary activity do not confirm natural origin. They confirm appearance consistent with comet. Appearance is not proof of nature. This is the frustration. Every observation adds information but not clarity. More data. Same ambiguity. Multiple interpretations remain viable. October 28. Yesterday, new data emerged. NASA's Neil Gehrels Swift Observatory detected hydroxyl emission from 3I Atlas. Hydroxyl, OH radical, chemical fingerprint of water. When water molecules break apart under solar ultraviolet radiation, they produce hydroxyl. Detecting hydroxyl confirms water ice is present, is sublimating, is creating the observed coma. Scientists called this a major breakthrough. Quote from the team: "This detection confirms water activity and provides insight into cometary evolution. The hydroxyl signature appeared exactly where expected for natural comet at this distance from Sunday temperature sufficient for water ice sublimation. Intensity matching predictions for object of this size, more evidence for natural interpretation, more support for Statler's position. Water ice, hydroxyl emission, coma development, tail formation, everything a natural comet should do. But again, this does not rule out alternatives. Artificial object could carry water ice for propellant, for radiation shielding, for thermal control. Detecting water does not prove natural origin. It proves water is present. Composition tells us what, not why. The debate continues because both sides can explain the observations within their frameworks. Natural comet framework explains everything through known chemistry and physics. Technological framework explains the same observations as mimicry or functional requirements. Data does not distinguish between frameworks because both predict similar observables. What would distinguish them? What observation would definitively prove one interpretation over the other? Trajectory deviation. That is the smoking gun. If the object emerges in December at a position different from gravitational predictions, non-gravitational acceleration occurred. If that acceleration exceeds what cometary outgassing can produce, technological propulsion is confirmed, clear, unambiguous, definitive, or detection of artificial signals, radio emissions, optical pulses, patterns that cannot occur naturally. SETI protocols exist for signal detection, verification procedures, confirmation requirements. If 3I Atlas transmitted anything technological, we would know. Or surface features inconsistent with natural formation. If the high-rise image from October 2 were released and showed geometric patterns, regular structures, anything suggesting manufacturing, that would be definitive. Right now, that image sits in an archive. Unreleased, we cannot see it. Or deployment of secondary objects. If smaller craft, separate from main body, if they follow independent trajectories, if they maneuver toward different targets, that would be proof. Harvard paper predicted this possibility, calculated that perihelion today would be optimal deployment point. If many probes were released, we will detect them over the next few weeks. Or we will not. Clear test, 33 billion tons. Let's return to that number, because understanding that mass is critical to understanding why this moment matters so much. Scientists calculated mass from brightness and size estimates. Brightness tells us how much sunlight the object reflects. Size comes from brightness plus assumptions about surface reflectivity. Call that albedo. Typical cometary albedo is around 4%, very dark, absorbing most sunlight, reflecting little. Using 4% albedo and observed brightness, diameter comes out roughly 2.7 kilometers. Volume follows from diameter, assuming reasonable shape. Roughly ellipsoidal, 4:1 length to width ratio. That gives volume around 10 cubic kilometers, 10 billion cubic meters. Density determines mass. Typical cometary density is 2 to 3 grams per cubic centimeter. Rocky ice mixture. Not solid rock, not pure ice. Somewhere between. Use 2.5 grams per cubic centimeter. Multiply by volume. Result: approximately 33 billion tons. Let that sink in. That is 5,000 times the mass of the Great Pyramid of Giza. The Great Pyramid masses roughly 6.7 million tons. Stone blocks. Solid limestone. One of the most massive structures humans ever built. 3I Atlas outmasses it 5,000 to 1, or compared to Mount Everest. Not the entire mountain, just the above-ground portion. The peak rising above sea level. Estimated mass, around 30 billion tons. Roughly equivalent, an entire mountain's worth of material, traveling at interstellar velocities. Approaching our Sunday. This mass matters for propulsion calculations. If this object is artificial, if it performs maneuvers, thrust requirements scale with mass. Accelerating 33 billion tons requires enormous energy. Chemical rockets insufficient. Nuclear propulsion possible but challenging. More exotic technologies would be needed. Fusion, antimatter, concepts beyond current human capability. If natural comet, mass, determines gravitational binding, how much force holds the nucleus together? Whether thermal stress can fragment it. 33 billion tons gravitationally binds strongly. Would resist disruption. Would survive perihelion heating unless internal weaknesses exist. The mass is key to predictions. Large mass means powerful forces required for maneuvers. Natural comet of this mass should survive perihelion intact. Artificial object of this mass demonstrates advanced capabilities if it maneuvers. December will show which interpretation matches reality. Here's what would need to be true if this is natural comet. First, formation in another star system under conditions producing 7.6 to 1 CO2 to water ratio. That star system must have chemistry different from ours. Different volatile distribution. Different ice line locations. Not impossible, but requiring specific formation environment. Second, ejection from that system into interstellar space. Gravitational interaction with planet, or stellar encounter, or supernova shockwave. Something powerful enough to accelerate it to escape velocity. Then billions of years drifting through galaxy, surviving radiation, surviving impacts with interstellar dust, arriving here intact. Third, random trajectory, aligning with 4 major planets at low inclination. Probability 0.005%, 5 in 100,000. Unlikely, but not impossible. Statistics allows rare events. This would be that rare event. Fourth, perihelion timing behind Sun from Earth is coincidence. 7% probability, again possible. Again coincidental if combined with other factors. Fifth, nickel signature from unusual organic chemistry, low temperature sublimation, molecular carriers not seen in solar system, plausible under different formation conditions, not proven but defendable. If all 5 factors align naturally, This is fascinating but entirely natural interstellar comet. Unusual, but explainable. The universe is vast. Statistics guarantees occasional weird outliers. Maybe this is one. Here's what would need to be true if this is technological. First, another civilization exists. Advanced enough for interstellar travel. Motivated to send probes to other star systems. Not proven, but statistically plausible given billions of stars in galaxy and billions of years of time. Second, probe design mimics cometary appearance, deliberate camouflage, or functional requirement. Ice for propellant, for shielding, for thermal control, creating natural-looking coma as byproduct. Technological explanation for why it looks like comet. Third, trajectory deliberately targets multiple planets, not random, planned. Reconnaissance mission surveying inner solar system. Multi-planet flyby sequence designed for maximum information gathering, explaining low probability geometry through intent rather than coincidence. Fourth, perihelion timing behind Sun is strategic. Optimal moment for concealed maneuver. Using solar occultation for cover, explaining 7% probability through planning rather than chance. Fifth, mass indicates capability. 33 billion tons suggests civilization with resources and technology far beyond human current level. Not impossible given sufficient time and development, just very advanced. If these 5 factors align technologically, this is first contact. Probe from another civilization. Historic moment. Civilization-altering discovery. Both frameworks explain the observations. Both require some unusual assumptions. Natural framework requires stacking low-probability natural events. Technological framework requires assuming advanced civilization exists and sent probe here. Which is more likely? Most scientists say natural. Loeb says technological possibility deserves investigation. Probability is unclear. Evidence is ambiguous. Answer comes in December when trajectory is measured. Right now the test is happening. Behind the Sunday hidden. Either disintegration or maneuver. Either natural death or artificial action. Nature is conducting the experiment. We are waiting for results. 5 weeks feels eternal when waiting for most important answer. But here's what we do know with certainty. This object changed how we think about interstellar visitors. Before 3I Atlas, we had 2 examples. Oumuamua, with its bizarre acceleration. Borisov, clearly natural comet. 2 objects, one weird, one normal. Insufficient data for patterns. 3I Atlas is the 3rd data point, the tiebreaker. And it falls somewhere between Oumuamua's strangeness and Borisov's normalcy. Unusual, but not definitively artificial. Natural, but not comfortably normal. Ambiguous in exactly the way that generates scientific controversy. That ambiguity is valuable. It forces us to confront assumptions, to question frameworks, to develop better observation methods, to prepare for next interstellar visitor with better tools, better protocols, better questions. Whether 3I Atlas is natural or artificial, it teaches us how to investigate, how to gather data, how to analyze ambiguous evidence, how to distinguish natural from artificial when the distinction is subtle. Next time will be better. Next detection will benefit from lessons learned here. Better telescope coordination, faster response times, more comprehensive observation campaigns, pre-positioned instruments, pre-approved protocols. We are learning. Science is advancing. Capability is improving. And the universe keeps sending teachers in the form of interstellar visitors. 3 objects in 8 years. The rate is increasing. Or our detection capability is improving. Or both. Either way, more are coming. Next year, year after, decade after. Each one teaches. Each one tests our theories. Each one brings us closer to understanding what is normal and what is not. And eventually, if technological civilizations exist, if interstellar probes travel between stars, if galaxy contains intelligence sending scouts, we will detect unambiguous proof, clear evidence, definitive confirmation. Maybe today is that day. Maybe 3I Atlas is that proof. Maybe what is happening right now behind the sun is the moment when humanity confirms we are not alone. Or maybe today is just another interesting natural comet and the wait continues. 5 weeks until we know which story is true. November 3rd, 5 days from today. That is the first post-perihelion test, Venus flyby. 97 million kilometers, 60 million miles. Close enough for detailed observation if anyone is watching. If anyone prioritized this object enough to point the right instruments at the right time. Here's the problem. Coordination takes time. Planning. Resources. Approvals. 5 days is barely enough to organize comprehensive observation campaign, especially when institutional consensus says this is just a comet, just an unusual but natural object, not worth extraordinary efforts. But if Loeb is right, if something deployed during perihelion, if many probes separated from main body, Venus flyby might reveal them. Secondary objects on independent trajectories, heading toward inner planets. Smaller, faster, maneuverable. Clear proof of artificial origin if detected, or we see nothing. Main object passes Venus exactly where gravity predicts. No secondary objects, no anomalies, no surprises. Natural comet confirmed. Controversy over. Loeb was wrong. Science wins through mundane explanation. Binary outcome, 5 days away. But that is just first test. Real answer comes later, December 19th. That is the big one. Closest approach to Earth. 267 million kilometers, 166 million miles, farther than Mars orbit, closer than asteroid belt, within range of every major telescope on planet, professional observatories, amateur astronomers, thousands of instruments, coordinated observation, distributed capability. This is where citizen science becomes crucial. NASA might control space telescopes. Universities might control major observatories, but amateurs control thousands of smaller instruments worldwide. Backyard telescopes, automated tracking systems, image processing software, online coordination platforms. If something unusual occurs, someone will see it. Multiple independent observers, cross-verification, crowdsourced data analysis. No single institution can gatekeep this observation. Too many eyes, too much capability, too distributed. That democratization is beautiful. Science becomes accessible. Public participates directly. Data flows freely. Institutions cannot suppress or delay information when thousands of independent observers are watching simultaneously. December 19th will be transparent, open, verifiable. Whatever happens, we will know quickly, not after weeks of institutional review, not after committees deliberate, immediately. Real-time reporting, social media updates, live observation streams. That is new. That is unprecedented for interstellar object observation. Oumuamua was discovered after peak brightness. After closest approach, only professionals tracked it. Data filtered through institutional channels slowly. Borisov was better observed, but still primarily professional domain. 3I Atlas is different. Maximum visibility occurs at Earth closest approach. Amateurs are prepared. Equipment is ready. Coordination is established. This will be most publicly observed interstellar object ever. And what happens if something appears that should not be there? What if December 19th reveals anomaly? Object in wrong position. Secondary craft detected. Unusual emissions observed. Clear deviation from natural predictions. Then everything changes. 33 billion tons. Let's return to that number one more time, because understanding that mass reveals why the stakes are so high. Scientists couldn't process it when calculations first came back. 33 billion tons. Let that sink in. That is 5,000 Great Pyramids of Giza stacked together. Each pyramid masses roughly 6.7 million tons. Limestone blocks. Solid stone. One of most massive human constructions ever built. Multiply that by 5,000. That is 3I Atlas, or compared to Mount Everest above ground mass, the peak rising above sea level, rock, ice, snow, entire mountain structure, estimated 30 billion tons, roughly equivalent to this object. An entire mountain traveling through space at interstellar velocity. This number breaks every model for interstellar visitors. Oumuamua massed maybe 75 million kilograms. Borisov, around 400 million kilograms. 3I Atlas is 80,000 times more massive than Oumuamua, 10,000 times more massive than Borisov. This is not small rock. This is planetary-scale object. That mass has implications. Gravitational binding strength, structural integrity, resistance to thermal stress. 33 billion tons does not fragment easily, does not break apart under solar heating unless internal weaknesses exist. Should survive perihelion intact unless composition is unusually fragile. That mass also has propulsion implications. If artificial, if maneuvering, accelerating 33 billion tons requires enormous energy. F equals ma. Force equals mass times acceleration. Want to change velocity by 1 meter per second? Need 33 billion newtons of force applied for 1 second. Chemical rockets insufficient. Nuclear thermal possible but challenging. Fusion. Antimatter. Technologies beyond current human capability required. So if trajectory deviates in December, if position is wrong, if delta V was applied, the implications are staggering. Not just confirmation of artificial origin, confirmation of civilization far more advanced than us, capable of moving mountain-sized masses across interstellar distances, capable of precision navigation, capable of entering another star system deliberately. That is what 33 billion tons means. That is why this number matters so profoundly. Small probe might be accident, might be derelict, might be ancient artifact, but 33 billion ton object executing deliberate maneuver demonstrates active capability, current operations, functioning technology, present tense intelligence. Let that sink in. If December reveals maneuver, we are not just confirming life exists elsewhere. We are confirming advanced technological civilization exists and is capable of reaching us, capable of observing us, possibly capable of interacting with us. Ready or not, that changes everything. Step back from the technical details for a moment. Consider the bigger picture. Our place in universe, human significance, cosmic loneliness. These questions have haunted us since we first looked up at stars and wondered, are we alone? For thousands of years, that question had no empirical answer. Philosophy, religion, speculation, but no data. No evidence, either way. Just wondering, just hoping or fearing, depending on perspective. Then we developed telescopes, discovered planets around other stars. Thousands of exoplanets. Billions more predicted. Planets everywhere. Some in habitable zones. Some Earth-sized. Some with atmospheres. Some possibly hosting life. Statistical arguments emerged. Drake equation, Fermi paradox. Calculations suggesting galaxy should be full of civilizations. but also questions about why we see no evidence. Why silence? Why no signals? Why no visitors? Maybe we are rare. Maybe life is common, but intelligence is rare. Maybe intelligence is common, but technological civilization is rare. Maybe technological civilizations destroy themselves before becoming interstellar. Maybe they exist, but travel is too difficult, too expensive, too slow. Or maybe they are here. Maybe we just did not recognize them. Maybe 3I Atlas is one. Maybe Oumuamua was one. Maybe dozens pass through undetected every decade and we only catch the unusual ones. 3I Atlas forces us to confront these questions, not as abstractions, but as immediate possibilities. Is this object natural or artificial? That question is answerable, testable, resolvable through observation. Within weeks, we will have data. Within months, we will have answer. And that answer determines our place in cosmos. If natural, we remain uncertain, still searching, still wondering. But if artificial, we graduate. From childhood wondering to confirmed knowledge, from alone to accompanied, from isolated to connected. That transition is profound. Philosophically, psychologically, socially, politically. Every framework gets questioned. Every assumption gets challenged. Religion adapts or struggles. Science expands or fractures. Governments cooperate or compete. Humanity unifies or divides. Nobody knows how we respond. No protocols exist, no preparation occurred, no consensus exists on what first contact means or how to handle it. We are improvising, if it happens, making it up as we go, hoping wisdom and cooperation prevail over fear and competition. But maybe December shows us nothing unusual. Maybe 3I Atlas appears exactly where predicted. Maybe all anomalies resolve naturally. Maybe this was just fascinating but entirely natural interstellar comet. Unusual but explicable. Then life continues. Question remains unanswered. Search continues. But we learned. We practiced. We developed better methods, better coordination, better preparation. Next interstellar visitor gets better observation, better data, better analysis. That is still valuable. That is still progress. Even null result teaches us. Even negative result moves science forward. Even natural explanation adds to our understanding of how comets form in other star systems, how they survive interstellar transit, how they interact with our Sunday. But here's what troubles some scientists. Here's what keeps them working late. Here's what makes them recalculate probabilities over and over. The pattern, the stacked coincidences, the multiple low probability factors all aligning. Right now, at this exact moment, an object vanished, disappeared behind our star. Every telescope on Earth is blind. Every observatory powerless. Scientists cannot see what happens next. And that invisibility might be the most suspicious thing about it. Two predictions exist. Opposite predictions. One says natural death. One says artificial maneuver. Both cannot be right. Click subscribe. Is this the perfect coincidence or the perfect cover? Natural comet or technological probe? Comment below with your answer. In the next 45 minutes, you will discover why NASA is withholding the best image ever taken, why Harvard calculated a 0.005% probability this trajectory is random, and why the next 37 days will answer the oldest question humanity has ever asked. Here's the problem. The best image exists right now. Sitting in a data archive, you cannot see it. Neither can any scientist outside a small group with access. October 2nd, 27 days ago. The high-rise camera aboard Mars Reconnaissance Orbiter captured this object from 30 million kilometers away. That is 1/5 the distance from Earth to Sunday close. Incredibly close for spacecraft observation. High-rise stands for High-Resolution Imaging Science Experiment, the most powerful camera humanity ever sent to another planet, designed for geological survey of Mars' surface. Resolution: 30 centimeters per pixel from 400-kilometer orbit altitude. At 30 million kilometers from 3I Atlas, that translates to roughly 30 meters per pixel resolution. Compare that to everything else available. Hubble Space Telescope from Earth achieved maybe 200-meter resolution at best. 10 times worse. Ground-based observatories even worse due to atmospheric distortion. The high-rise image would show surface features, structure details, shape precision, critical data that no other instrument could capture. Dr. Avi Loeb from Harvard University requested that image. Standard scientific protocol. He wrote to the principal investigator. University of Arizona operates high-rise. NASA funds the mission. Data should be public, taxpayer-funded, available to researchers. No response came. He followed up. Still nothing. He followed up again. Still silence. October 2 became October 10. October 10 became October 20. October 20 became October 28. 3 weeks of institutional silence while the most important interstellar object ever detected approached its critical moment. Yesterday, Loeb went public. The Joe Rogan Experience podcast. Millions of listeners, massive platform. He used direct language. Quote, "This is not about extraterrestrial intelligence, but about terrestrial stupidity." Terrestrial stupidity. Strong words from a former chair of Harvard's astronomy department. Not conspiracy theory. Not cover-up accusation. Institutional incompetence. Bureaucratic failure to recognize significance. Here's what makes this suspicious. The timing. October 2nd, perfect opportunity. Best resolution achievable. Then 3 weeks of silence. Then today, October 29, Perihelion. The object disappears behind the Sunday. The window for coordinated observation closes. If that image showed unusual surface features, scientists needed it before today, before the object vanished, to plan follow-up observations, to coordinate instruments, to test hypotheses during the critical moment. That window closed hours ago. 3 explanations exist for the silence. First, simple bureaucratic failure. The request fell through administrative cracks. Nobody prioritized it. Standard institutional inefficiency, not malice, just incompetence. Second, deliberate caution. Someone reviewed the image, saw something unusual, decided to withhold pending extensive peer review. Institutional risk aversion. Third, the image shows nothing interesting. Standard cometary nucleus. Nobody prioritized release because it adds nothing new. All 3 are plausible. None is satisfying. But the result is identical, regardless of motive. The best image remains hidden. Public suspicion grows. Institutional credibility erodes. Social media explodes with speculation. And the object just vanished behind the sun while we remain blind. Here's the problem with that perihelion timing. If this were random, if the closest approach to the sun naturally occurred on the far side from Earth perspective, probability is roughly 7%, 1 in 14. Not particularly suspicious alone, but combined with everything else, the coincidences stack. Multi-planet encounters, near ecliptic alignment, hidden perihelion, unusual composition, institutional silence. Each individual factor has innocent explanation. The pattern does not. Dr. Loeb published analysis calling today the acid test, Harvard Center for Astrophysics paper. Calculated orbital mechanics. Ran the numbers. Concluded, if this object has technological origin, perihelion represents optimal moment for specific maneuver. Reverse solar Oberth maneuver. Let me explain that concept because understanding it is critical. An Oberth maneuver is spaceflight technique discovered in the 1,920 seconds. The principle is elegant. When you apply thrust at point of highest velocity, you get maximum efficiency. Physics amplifies effort. Kinetic energy magnifies thrust effectiveness. Spacecraft use this constantly to gain velocity. Fire engines at periapsis. Close approach to gravitational body. Moment of maximum speed. Gain more delta V for same fuel expenditure. Now reverse the concept. Instead of speeding up, slow down. Instead of escaping, get captured. If your goal is remaining bound to a star system after entering on hyperbolic trajectory, reverse Oberth braking at perihelion is optimal. Apply maximum thrust at highest velocity. Convert hyperbolic orbit to elliptical. Stay in system long-term instead of escaping to interstellar space. The math is beautiful. The efficiency is maximum. The timing is today. And it happens behind the sun, where Earth cannot observe. Perfect concealment, or perfect coincidence. Dr. Tom Statler from NASA has opposite view. He is lead scientist for solar system small bodies at NASA headquarters. His assessment, published in September and reaffirmed multiple times, is unambiguous. It looks like a comet. It does comet things. Evidence overwhelmingly points to natural body. 770 watts per square meter of solar heating at perihelion should cause massive outgassing. Bright plumes of gas, potentially nucleus fragmentation. That is what natural comets do under intense thermal stress. Ice sublimates, gas expands, pressure builds. Sometimes nuclei crack apart. If Statler is correct, that is happening right now, behind the Sunday hidden from view. When the object emerges in December, we will see fragments, or at minimum, significantly increased brightness from outgassing surge. But if Loeb is correct, something else happens right now. Thrust application, velocity change, trajectory alteration, artificial object executing calculated maneuver, using solar gravity for efficiency, hidden by solar occultation. Two hypotheses, opposite predictions, one correct, one wrong. December reveals which. 5 weeks until we know. But the test is happening at this moment, behind the Sunday. Right now, as you read these words, the controversy did not emerge from nowhere. It emerged from 4 months of observations, from measurements, from documented anomalies that mainstream models struggle to explain comfortably. Go back to the 1st of July 2025, Discovery Day. The Asteroid Terrestrial Impact Last Alert System in Chile detected unusual motion. Atlas, automated survey scanning for near-Earth objects. The system flagged something with strange trajectory, moving too fast. Not bound to Sunday. Interstellar. Within 72 hours, follow-up observations from multiple telescopes confirmed hyperbolic trajectory, eccentricity greater than 1, velocity exceeding solar system escape speed. This object entered from outside, passing through, not captured, not orbiting. The third interstellar object ever confirmed, after Oumuamua in 2017, after Borisov in 2019, 6 years between second and third detection. Building dataset, creating comparison opportunities, learning what interstellar visitors look like. International Astronomical Union assigned designation 3I Atlas. Third interstellar, simple, standard, but understanding came harder. Size estimates emerged from brightness measurements. Reflected sunlight intensity combined with assumptions about surface reflectivity suggested diameter between 2 and 3 kilometers. Large, much larger than previous interstellar visitors. Oumuamua measured maybe 200 meters long. Borisov, roughly 1 kilometer. This was substantially bigger. Then detailed observations began revealing anomalies. The Very Large Telescope in Chile pointed spectrographs. 8.2-meter mirror. powerful instrument, breaking reflected sunlight into component wavelengths, identifying chemical signatures by spectral fingerprints. Late July observations showed nickel emission, atomic nickel vapor in the coma surrounding nucleus, clear spectral lines, unambiguous detection, but missing corresponding iron lines that normally accompany nickel in natural bodies. Nickel and iron are chemically similar, travel together in cosmic environments, sublime at similar temperatures. Solar system comets show both together. 3I Atlas showed nickel without iron. Professor Darrell Seligman from Michigan State University led the spectroscopic analysis. His team published findings in October. Interpretation: nickel bound in organic molecules, carbon monoxide compounds, sublimating at low temperatures as object approached Sunday, solar ultraviolet radiation breaking molecular bonds, releasing nickel atoms. Natural chemistry: unusual but explainable by formation conditions in different star system. Dr. Loeb offered different interpretation. Nickel without iron matches industrial alloy signature, specifically nickel tetracarbonyl, compound used in manufacturing, metal refining processes, never observed in any natural comet, never detected in any solar system object. If this spectral signature is nickel tetracarbonyl, implications are significant. Two experts examined identical data. Both understand spectroscopy. Both know the analysis techniques. Both published peer-reviewed research. Yet they reached opposite conclusions. This pattern repeated in August. James Webb Space Telescope observed 3I Atlas, JWST, at Lagrange Point 2, 1.5 million kilometers from Earth, away from our planet. Infrared instruments unobscured by atmosphere. Spectroscopy at wavelengths human eyes cannot detect. JWST observed for 8 hours total across multiple sessions. Near-infrared spectrograph detected molecular absorption lines, carbon dioxide, water vapor, carbon monoxide, methane traces, building compositional profile. Results showed carbon dioxide dominating emission, CO2 to water ratio, 7.6 to 1. Most solar system comets show ratios near 1 to 1, sometimes 2 to 1. 7.6 to 1 is unprecedented, outside the range of any previously studied comet. Seligman's team offered natural explanation. Formation location near CO2 ice line in home star system. Distance where carbon dioxide freezes but water remains gaseous. Object condensed there billions of years ago. Locked in that ratio. Traveled through interstellar space carrying chemical signature of alien stellar environment. Plausible, natural, but requiring that distant system to have different chemistry than ours. Another unusual factor stacking on the list. Then, trajectory analysis revealed more surprises. Orbital calculation showed multi-planet encounters. Venus flyby November 3 at 97 million kilometers. Mars passage already occurred October 2 at 30 million kilometers. Earth closest approach December 19 at 267 million kilometers. Jupiter encounter the 16th of March 2026 at 54 million kilometers. 4 major planets. 1 trajectory. Harvard Center for Astrophysics calculated probabilities. Monte Carlo simulations. Millions of random trajectories. Counting how many produced similar geometry. If you randomly enter solar system from any direction, what are odds of passing 4 major planets within these distances? 0.005%, 5 in 100,000. If this trajectory is random, if this object just happened to enter from coincidental direction at coincidental time, probability is extraordinarily low. Not impossible. Statistics allows unlikely events, but noteworthy. Suspicious. Deserving. Investigation. Then orbital inclination added another low probability factor. Most interstellar objects should arrive from random angles. Three-dimensional space offers infinite approach directions. Statistical expectation? High inclination. Steep angles to ecliptic plane where planets orbit. But 3I Atlas arrive nearly aligned with ecliptic. Inclination approximately 5 degrees, almost in planetary plane, where gravitational interactions are strongest, where multi-planet encounters become possible. Probability of random inclination this low? 0.2%. 2 in 1,000. Stacking on multi-planet probability. Multiplying unlikelihood. Harvard paper presented this analysis. Hibbard, Crowell, Loeb. Published July through Harvard CFA. Title: Is the interstellar object 3-1 Atlas alien technology? The paper does not claim proof. Claims probability stack justifies serious investigation of technological hypothesis. NASA pushed back. Statler's response: Natural explanations exist for every observation. Unusual composition reflects different star system chemistry. Large size is statistical variation. Multi-planet trajectory is rare but possible. Inclination is coincidence. No evidence requires alien technology. Both sides make arguments. Both cite data. Both use rigorous methods. Yet conclusions differ fundamentally. This is frontier science. Ambiguous data. Competing frameworks. Standards of evidence in dispute. Right now, the object is behind Sunday, subjected to intense heating. Either fragmenting, as Statler predicts, or maneuvering, as Loeb suggests. Both predictions are testable. Both produce observable consequences. December reveals which, if position matches gravitational predictions exactly. Natural comet confirmed. If position deviates, if trajectory changed, everything changes. 5 weeks separate us from answer. But test is happening now. This moment. Behind Sunday hidden. Thank you for staying with us. Please subscribe, share, and hit the like button. The scientific divide is not just about data interpretation. It is about people, about careers, about reputations built over decades, about institutional incentives that shape what questions get asked and which hypotheses get investigated. Dr. Avi Loeb is not fringe scientist. Professor of Science at Harvard University. Former chair of Astronomy Department. Published over 1,000 papers. H-index exceeding 130. That measures scientific impact. Citations, influence. He is establishment. Was establishment. Until Oumuamua. In 2017, first interstellar object passed through solar system. Oumuamua, Hawaiian word meaning scout. Strange elongated shape. Unusual acceleration beyond what gravity predicted. Loeb published papers suggesting possible artificial origin, light sail, probe, technology from another civilization. The astronomy community reacted harshly. Mainstream scientists called it sensationalism, irresponsible speculation, damaging to science. Criticism was fierce, public, personal. Most astronomers dismissed hypothesis entirely, preferred natural explanations. Nitrogen iceberg, hydrogen iceberg, dust aggregate, anything but artificial. Loeb did not back down. Founded the Galileo Project. Private funding. Systematic search for technological signatures. Telescopes. Sensors. Ongoing today. When 3I Atlas appeared in July, Loeb immediately applied same questioning framework, looking for anomalies, calculating probabilities. Publishing findings that challenge mainstream interpretation. Is this brave scientific inquiry or stubborn refusal to accept simpler explanations? The community is divided. Supporters say science progresses through questioning orthodoxy, through investigating low-probability hypotheses, through challenging assumptions. They point to history. Continental drift, dismissed for decades. Meteorites, rejected as myth. Black holes considered impossible, all proven eventually. Critics say extraordinary claims require extraordinary evidence. They invoke Occam's razor. Simplest explanation is usually correct. Comet looks like comet, acts like comet, therefore is comet. Invoking alien technology without definitive proof is speculation that confuses public and distracts from legitimate research. Both sides have valid points. This is not simple case of science versus pseudoscience. This is legitimate disagreement about methodology, about evidence thresholds, about resource allocation for investigation. But here's what makes 3I Atlas different from Oumuamua: timing. Oumuamua was discovered after perihelion, already leaving, already fading. Astronomers had only weeks before it became too dim. Most data came from reconstruction, modeling, inference. 3I Atlas was discovered before perihelion, months before. Scientists had time to prepare, to coordinate, to point best instruments. Hubble observed. JWST observed. Ground-based observatories tracked continuously. Spectroscopy, photometry, astrometry. Dataset is vastly larger, vastly more detailed, and anomalies persist. With better data, mysteries should resolve. Natural explanations should become obvious. But with 3I Atlas, more data brought more questions. Nickel signature, CO2 ratio, trajectory geometry. Each measurement added detail but not clarity. That troubles scientists. Even those who strongly favor natural explanation acknowledge the anomalies are real. They just interpret them differently. Natural but unusual versus potentially artificial. Same facts, different frameworks. Dr. Tom Statler represents mainstream consensus. His position is defensible. Natural comet. Interesting but natural. All anomalies explainable through known physics. He spent 3 days reviewing the spectroscopic data before issuing his September statement. Consulted with colleagues. Examined alternative hypotheses. Concluded evidence overwhelmingly supports natural interpretation. That is rigorous science. That is proper methodology. But Loeb argues the probability stack creates pattern that deserves investigation without prejudgment. Not claiming proof, claiming justification for serious inquiry. The institutional response has been mixed. Some observations were approved, some telescopes allocated time, but not the full court press that Loeb advocates. Not the coordinated multi-instrument campaign that would maximize data collection during limited visibility window. Why not? 2 reasons. First, mainstream consensus says natural comet. Allocating massive resources to investigate alien technology claims is not justified when evidence points to natural explanation. Telescope time is precious, competition fierce. Other priorities exist. Second, institutional caution. If this turns out to be nothing unusual, agencies look foolish for overreacting. Media circus, public mockery, wasted resources. Better to proceed carefully, methodically. Avoid hype. Both reasons are defensible from institutional perspective, but frustrating from investigation perspective, because window is closing. Each day, object moves farther from optimal observation geometry. Each week it dims. Each month it becomes harder to study. Opportunities are now, not later, not years from future when better telescopes exist. Now, and now is slipping away while committees meet and proposals get reviewed. Here's the problem with that caution. If object is natural, caution makes sense. Time exists. It will be studied. Data will accumulate. No urgency. But if object is artificial, caution is catastrophic. Missing the most important moment in human history. because of paperwork and risk aversion. Which is it? Nobody knows for certain. That uncertainty paralyzes decision-making. In absence of definitive proof either direction, institutions default to conservatism. Do not overreact. Do not waste resources. Wait for more data. But waiting consumes time we cannot recover. Right now, at this moment, perihelion is occurring. Behind Sunday hidden, the most critical moment. Either disintegration or maneuver. Either natural death or artificial action. And we are blind. Cannot observe, cannot measure, cannot verify predictions in real time. That blindness is either unfortunate geometry or strategic concealment, natural coincidence or deliberate timing. Interpretation depends on your framework, your assumptions, your threshold for considering unusual hypotheses. 5 weeks until December emergence. 5 weeks until trajectory measurements. 5 weeks until definitive answer. But those 5 weeks feel eternal when waiting for most important question humanity ever asked. If this is random, what else must be true? Universe must conspire to create perfect storm of unusual but natural factors. Multi-planet trajectory. Near ecliptic alignment. Hidden perihelion. Anomalous composition. Large size. Unusual nickel signature. All random. All coincidence. All explainable individually but suspicious combined. That is possible. Statistics allows unlikely events. Rare does not mean impossible. 5 in 100,000 trajectories do occur eventually, given enough objects. This might be that rare one, but if this is deliberate, what else must be true? Civilization must exist, advanced enough for interstellar travel, motivated to explore, capable of building 33 billion-ton probes, interested in our solar system specifically, choosing trajectory that provides multi-planet observations, using near-ecliptic approach for fuel efficiency, timing perihelion for optimal maneuver concealed behind Sunday. That is also possible. Statistically plausible given billions of stars and billions of years. Less probable than single-star civilization existing. But galaxy-wide, probably thousands or millions of technological civilizations, if life is even moderately common. 2 possibilities, both allowed by physics, both compatible with observation so far. Data does not yet distinguish. December might or might not. Ambiguity might persist even after more observations. Nature sometimes refuses to provide clean answers, but here's what we do know with certainty. We cannot measure everything. Our instruments have limits. Our methods have gaps. Some questions remain unanswerable with current technology. We cannot measure interior composition directly. Cannot see inside nucleus. Cannot determine if it is solid ice and rock or hollow shell. Cannot detect internal cavities or structures. Gravity too weak to measure from distance. Would need close flyby or landing for direct sampling. We cannot detect all possible emissions. Radio surveys covered some frequencies. Optical telescopes covered visible wavelengths. Infrared covered thermal emissions. But electromagnetic spectrum is vast. Countless frequencies, countless bandwidths. We sampled tiny fraction. If object transmits on frequency we did not monitor, we miss it. We cannot resolve small surface features. Best resolution from high-rise was 30 meters. Anything smaller is invisible. Engines, hatches, antennas, solar panels, all could exist below resolution limit. We see overall shape. We see large-scale features. We miss fine details. We cannot detect faint secondary objects. If many probes deployed, if they are small, if they are dark, if they are cold, we might miss them entirely. Detection thresholds exist. Below certain size or brightness, objects become invisible to our surveys. They could be there, we just cannot see them. We cannot predict all possible technologies. Our assumptions are based on our physics, our engineering, our limitations. Advanced civilization might have capabilities we cannot imagine, propulsion we do not recognize, materials we cannot detect, methods we cannot conceive. Absence of evidence is not evidence of absence when searching for unknown unknowns. These limitations matter. They constrain what we can conclude. They create uncertainty that persists regardless of observation quality. Perfect data within our technological limits might still miss critical information outside those limits. That is humbling. That is frustrating. But that is reality of scientific investigation at the frontier. We work with what we have. We push boundaries. We develop better tools. But we acknowledge gaps. We admit uncertainty. We avoid claiming certainty when ambiguity remains. Future technology will help. James Webb Space Telescope is good but not perfect. Next-generation telescopes will be better. Ground-based extremely large telescopes coming online next decade. Space-based interferometers planned. Better sensors. Better resolution. Better sensitivity. Future missions could visit directly. Spacecraft could chase interstellar objects, match velocity, get close. Sample material. Image surface. Measure properties directly. Several proposals exist for missions to next interstellar visitor. Launch on warning. Intercept during passage. Return data. Maybe return samples. That is how we will eventually answer these questions. Not from Earth-based observation alone, but from direct investigation, from touching, from analyzing, from eliminating ambiguity through presence. But that is future. That is years away. That requires funding, planning, political will, international cooperation. Not guaranteed, not simple, not quick. Today we have 3i Atlas behind Sunday. Tomorrow we have observations from distance. Next month we have trajectory measurements. That is what we work with. That is what we have. That is what must suffice. So where does this leave us? What happens next? What should we watch for? November 3rd, Venus flyby. Watch for position accuracy. Any deviation from predicted path suggests non-gravitational acceleration during perihelion. Watch for secondary objects. Anything on different trajectories suggests deployment occurred. Watch for spectroscopic changes. New emissions suggest activation. New activity. Something beyond passive outgassing. November 21st to December 5th. The window Loeb calculated for Earth intercept if deployment occurred. Watch for unusual objects appearing in cislunar space near Earth. In lunar orbit, heading toward planet. This is testable prediction. Clear time frame. Specific forecast. If something arrives, then hypothesis confirmed. If nothing arrives, hypothesis weakened significantly. December 19th, Earth closest approach. Watch for everything. Position, brightness, spectrum, morphology, fragments, secondary objects, every telescope, every wavelength, every technique, maximum effort, maximum data collection. This is the observation that matters most for public science, for distributed observation, for transparent investigation. The 16th of March 2026. Jupiter encounter. Watch for gravitational deflection. Path bends around Jupiter predictably if pure gravity. Path deviates if propulsion occurs. Watch for Juno observation if NASA approves. Spacecraft in Jupiter system. Could observe from close range. Could provide best data since October high-rise image if anyone bothers to look. 4 milestones, 4 opportunities, 4 tests of competing hypotheses. Each one teaches, each one constrains possibilities. Each one brings us closer to answer. And by March 2026, by spring next year, we will know. Not everything, not with certainty, but substantially more than today. Substantially more than we knew in July. The arc of investigation bends toward knowledge, slowly, ambiguously, imperfectly, but progressively. That is how science works. Not revelation, not sudden clarity, gradual accumulation, incremental progress, competing interpretations narrowing as evidence accumulates. Eventually, consensus emerges. Eventually, answer becomes clear. Eventually, even skeptics and advocates agree. Maybe 3I Atlas reaches that consensus by March. Maybe ambiguity persists longer. Maybe we never know for certain because data quality insufficient. But we try. We observe. We analyze. We discuss. We refine. That process is science. That process is valuable regardless of final answer. The 29th of October 2025, today, right now, this moment. Perihelion. Behind Sunday hidden. Test occurring. Nature conducting experiment. We await results. 5 weeks until preliminary answer. 5 months until comprehensive answer. But happening now, this instant, while you read these words, 33 billion tons either obeying physics or defying it. Either fragmenting naturally or maneuvering artificially. Either confirming we understand comets or forcing us to expand understanding dramatically. Binary choice, one correct, one wrong. December reveals which. Are you ready for that answer? Ready if it confirms natural comet? Ready if it confirms artificial origin? Ready for certainty either direction? Ready for implications either way? Most people are not ready. Most have not considered seriously. Most dismiss possibility of artificial origin as science fiction, as fantasy, as impossible. But physicists disagree. Biologists disagree. Astronomers disagree. Many experts say not only possible but probable given vast time and vast space available. Maybe today is the day that probability becomes reality. Maybe today is when humanity learns we are not alone. Not in galaxy, not in universe, not in anything. Accompanied, observed, perhaps even visited. Or maybe today is just another day. Just another comet. Just another natural object passing through. Unusual but natural. Interesting but mundane. And search continues. And wondering persists. And loneliness remains. 5 weeks until we know which story is true, which history we inhabit, which future we face. Remember the 29th of October 2025. Remember perihelion. Remember the moment when 33 billion tons disappeared behind the sun and 2 scientists predicted opposite outcomes, and humanity waited to see which prediction nature validated. This is that moment. Right now, today, the acid test completing, the results pending, the answer coming. Thank you for staying with us. Please subscribe, share, and hit the like button.